Okay, so your first question is asking you about a girl who's swimming. She swims a length of a pool that's 50 meters, and she does it at a constant speed. She swims one length every minute. The only issue with this is I'm not 100% sure what they mean by length. So if we have a pool, let's say she starts at point A, and the pool ends at point B. Lengths of a 50-meter pool at constant speed. So from point A to point B is 50 meters, right? And I assume they mean one length is just going from this end to this end. And coming back would be two lengths. I'm assuming that's what they mean. You might want to ask your teacher. Sometimes a length is considered back and forth, but we're going to assume it's just one distance and one back, okay? And it also takes her 1 minute to do this, okay? The question says, very first, graph her distance. Okay, so it says to graph it in terms of time and distance. So essentially what we want to think of is this is her starting point on the graph, okay? And because this is done in meters, we'll go 10, 20, 30, 40, and we know 50s is technically as far as she can go. It says she swims at a constant speed, correct?
Mm-hmm.
Yeah. Yeah, so then we're dealing with a straight line, and it's done in minutes. So let's say we'll do this is in minutes, okay, and this is in meters. That's 1, 2, 3, 4, 5, right? Yeah, okay. So, in other words, it takes her a minute to swim 50. So she'll be, for 1 minute, that's what her distance is from the starting point. She's now 50 meters away at 1 minute. Then she turns around in the pool and swims towards where she starts, correct?
Mm-hmm.
So then it takes her 2 minutes to get there. So to go there and back takes 2 minutes. And then this is a periodic function. So in other words, this is a pattern that repeats. Down. Okay. And it doesn't tell us how long she swims for, but for argument's sake, we'll just say it's 5 minutes. Okay. So this is a periodic function. This would be the graph. We're at 0 when she starts. So we're at 0 minutes when she starts, and we're also at our starting point. So we're 0 meters away. She swims 50 meters away. Takes her a minute, and then it takes her another minute to swim back to where she started from. So we go up and down. This would be question A already. We've already done question A, right? Graphing it. Does that make sense, Graham? Yeah? Okay. Determine the period and amplitude. So a period is how long it takes for a function to repeat. So in other words, I wish we had other colors. I'll just use it. What it is they want you to go from the starting point, and how long does it take you to get back to the starting point and then head in that direction. So if this is our starting point, it takes her 2 minutes to get back to that starting point. She swims away, comes back, and then she's heading in the same direction again. Okay? So the period of this function is 2 minutes. Yeah. The amplitude has to deal with, you have to find the equation of the axis of a function in order to find amplitude, okay? So in other words, amplitude is essentially half how far something is. The equation of the axis is a line that goes through the middle. So in ours here, okay, a line that goes through the middle, I can quickly tell by looking at this. Yeah, it's going to be 25. It's just going to be half, right? Because we know at 25 is halfway between 0 and 50. So our amplitude then deals with, from the equation of the axis, how far is it for us to get to the highest point, and then how far is it for us to get to the lowest point. Well, I know it's 25 meters up this way and 25 meters down this way. So the amplitude can be solved by just adding the lowest and highest points and then dividing by 2. So you can use it as an equation. You call it your, yeah, max minus min. They usually have to call it peaks and troughs. Does she call it that with you guys? A peak and a trough?
Well, just like for the beginning, you usually have the formula max and
Max and min. Okay, so let's call it max and min if that's what you're used to. Okay, so the maximum point plus the minimum point. It'll be max plus min divided by 2 will give us the equation of the axis.
Yeah.
Okay, so if I'm at, like, say it was 30 and 50, if I add them two together, 40 would be in between. So I'd have 80 divided by 2 is 40. So this gives us equation of axis. And then you're right, for amplitude, it's max minus min divided by 2, and that gives us our amplitude. Luckily, in this question, they happen to be the same thing, right? 25 and 25. It's not going to make a difference. Does that make sense? Okay. After state the domain and range, does it say how long she swims for? Okay. Domain and range deals with the height. So again, max and min, and then it also deals with time, so your x-axis. Domain specifically deals with x-axis. Okay, so I assume she would give it to you something like this. X is every real number, and then we put restrictions on it. Okay, because we start at 0, we definitely have the restriction of 0. She doesn't start swimming before time starts. That doesn't make any sense. But the question also doesn't tell us when she stops. So let's just assume she swims forever. She's an amazing swimmer. She's going to swim the rest of her life, okay? Unless they specifically ask for your domain and range of your graph, okay? If they ask for a graph, it's between 0 and 5. But if they just say what the domain and range in general, well, technically they didn't give us an ending point, so she could go on. This is a periodic function, so it could go on forever. So in other words, our only restriction is that x is greater than and equal to 0. That would be technically our only restriction. Unless they said of our graph, and if it's of our graph, it's that x is every real number between 0 and 5. Oh, greater than less than. Okay, does that make sense? So it's obviously one of those two. Our range is more straightforward. We have a max point of 50 and a minimum point of 0, so it's very easy. There's no questions about our range. Our range is y is the set of all real numbers, such that y is greater than or equal to 0 and less than or equal to 50. Does that make sense? Okay. And then finally, let's read that part of the question. Let's talk about that quickly. Okay, so what we figured out is we said that she swims 10% faster, right? So we know that a minute is 60 seconds. And if I multiply 10% of 60, 60 times 0.1 is 6. So we know she's going to save 6 seconds because she's swimming 10% faster. So I'd subtract that from 60, and that gives me my 54 seconds. She still swims the same length. Our length doesn't change. Okay. So now it takes her 54 seconds. So we're going to put a new graph. Sadly, we didn't scale this very well in terms of 54 seconds. So we're going to have to kind of estimate. Okay. We're going to say that 54 seconds is just a little before. Okay. So she starts at the same spot, but this time she gets to 50 meters a little faster, okay? And then, because this is in minutes, we're going to have to almost do this as a fraction of the idea. So it takes her 54 seconds for 1. Then obviously it's going to take her 54 seconds times 2 to figure out how long it takes her to get back, right? So we'll convert that because we can't just put it directly into minutes. So it's 108 seconds, which is a minute 48. So that's a minute 48, okay? 1 minute and seconds. Does that make sense to you? Okay. So now, a minute 48 is actually even a little farther this way than 2. It's probably around here. Okay. And then if we, again, add 54 seconds to 108, we're looking at 54 times 3. Because we got to do 6 length, right? So you know what? We might as well do all of them. 4, 5, and 6, because they're asking us how, whoops, times 6. They're asking us how long it takes for her to do 6 lengths, correct? This will be 12, 168 seconds. This will be, you want to convert them on the calculator while we're waiting? This will be 16 carry to 1. Yep. 324. Let's convert them to seconds. Divide them by 60, and then the remainder we'll have to do. So this will be 2 minutes 42 seconds.
Divided by what?
So you got to
5 by 60?
Yeah, so 60 goes in twice.
7.
All right, and then what you got to do is do the remainder. So you won't be able to do it very well on the calculator. So think of it like this: 60 goes into 216 seconds, goes in 3 times. Okay, it's 180. So that's, I know I'm at 180 minutes.
Is it like the stuff that you do with just like f at x or whatever, and you have to use the remainder?
It's just simple division, but using a remainder. It's just converting time right now, because right now we're in seconds. So and the problem is our chart is in minutes. What I could have done, if I had done this chart in seconds, like 10, 20, 30, 40, 50, 60 seconds, this would have been a lot easier. We wouldn't have to do all this converting. It'd be a lot easier to deal with, okay? But because we did ours in minutes, I have to do a whole bunch of converting. It's going to be like 36, 30, 4 minutes and 30 seconds. And then this is going to be 5 minutes and 24 seconds. So, our points are 242. 242 is like here, I think. So we go up. The whole point of this is to really show you the difference between the two graphs. It's a lot harder than it needs to be. 330. 330 is going to be here, almost. What do we got? 4 minutes, 30 seconds, and 5:24. So 4 minutes, 30 seconds, perfect, and then 5:24 is like back here. So the whole point of this.
Couldn't you just get the next point and add 54 seconds to it?
Yeah, you can do that. The only reason this is difficult, I don't know if you realize this yet, is this is in minutes. That's why I had to do all that converting. Okay? If you just did seconds, it would have been very, very simple. Yeah. But the question is, what is the difference in the graphs? What do you notice in the difference in the graph? What would be a way of describing it when we're doing like translations or transformations?
It's a compression.
Yeah, it's compressed horizontally, right? So we have a compression horizontally. Does that make sense? That was the whole idea to this question. Let's go next. Okay, question 8, they're talking about a Ferris wheel. They said the diameter of the wheel was 32 meters, and you figured out the radius was 16. Okay, so that means from the center, assume that's the center, I know I didn't draw it perfect, to here, 16 meters. And it said it was 18 meters above the ground. So how high above the ground is this wheel at its lowest point?
2.
Yes, at its lowest point, it's 2 meters above the ground. How high is this wheel at its highest point?
34.
Yeah, that's right. This is 34 meters above the ground. What about at its middle point? It's 2 middle points. How high above the ground is it at these points?
Oh, 18.
Right. Yeah, that's right. That would be the exact middle, right? So at 18, 18. It's always good to get like 4 corners here. Okay. So we figured that out so far. What was the next part you were doing here?
Graph the radius height above the ground in meters versus the time in seconds. During a 2-minute ride, the ride begins at the lowest point on the wheel. So I mean sine.
You can make it a sine or a cos function. It's up to you, because they're both a wave. It'd probably be easier to do as a sine function. Let's talk about how long does a revolution take? How long did the revolution say it took to get all the way around? Oh gosh, I didn't know here.
So it's 360 divided by 30, or it's like 12?
Well, let's just do it at points, right? So we're starting here. Let's assume it goes this way. Okay, so let's assume it goes like this, around the horn. Okay, so here we're at 0 seconds. Okay, what about to get halfway? How long is it going to take us? 15. And what about halfway between there?
It's 15 divided by 2. 7 by 5.
Yeah. What about a quarter of the way past that? What would I do?
15 plus 7 by 5.
Yeah.
That.
There you go. And then we're back at the beginning at 30 seconds again. Okay. So it's good that we have these reference points. They're going to help us when we go to draw this, okay? Let's bring in a graph.
So those are the points, and you just add on to it.
Mm-hmm. Just go like that.
And like double.
It's like that. Okay. Extend this. It's just a little slow. Okay. Okay, well that worked out pretty good. So, we know that it's going to take 30 seconds for an entire period to happen, for it to go all the way around. So, you know what? Let's go in intervals of, what time would you like to go in intervals of?
Can't we just do intervals that are 1 minute and 6 hours?
Let's go top and bottom intervals. Okay? Let's go top and bottom. So when it reaches a peak, so when it reaches its max and a minimum. Does that make sense to you? So this would be a max in terms of time. Time will be on the x-axis, okay? And this will be a min, okay? Just because these middle ones are going to be hard to show. I just wanted to make sure you had an idea of them, but they'll be hard to show. Let's just do the max and the min for now, okay? So we know at 15 seconds it'll reach a peak, so let's go from 0, 15, 30, 45, 60, 75, 90, 105, 120, 135, and 150. Okay? So these are all our points. Also, how high do we need to go?
34.
Okay, so we start at 0. We got to get to 34. So let's do intervals of...
She doesn't really care about if it's like even basically.
No, she doesn't?
She just makes us. She said just draw a graph and then just put the middle and label it and make it like it be like almost like equal.
That's awfully nice of her. Okay, so then one thing you do need to know though is that
it starts to go to.
Yeah, so this will be 2, let's say. We'll just say this is 34, okay? And what's our middle going to be?
16.
Close.
Is it 18? Oh, it's 18 because we have to add to this.
There you go. So our middle is at 18, okay? So when we go to graph this, we're starting point at 0. We know we're 2 meters above the ground, right? After 15 seconds, how high are we? Which is how high? 34. So after 15 seconds, boom, we're all the way up there. Okay? 30 seconds, where are we? Yeah. So we've set this up perfectly, so we can just go up, down, up, down. Is this making sense? Down, up. Now, because it's circular, it's not straight lines. It is a periodic function, so it's... We don't technically, because those times are going to be, because it's circular, they're not directly in between. Because at its max and min, the circle actually slows down. Or the Ferris wheel. Obviously, I'm not very good at it. It's a little easier when you do it freehand. Okay. So we take a look at this graph, okay? We've shifted everything. It's a big move now. So we have our peaks, troughs, or max or mins. 18 is not technically at 7.5 seconds. It could be a little different. I just wanted to give us an idea of reference points, but because it's circular, the speed of it changes. Okay, so at the bottom we're actually moving slower, but as we're coming up, we're picking up speed. We don't have to worry too much about that. Okay, so we've graphed the rider. Begins at lowest point. Determine the period and amplitude. So what's the period of this?
30 seconds?
Yeah, that's it. Period is 30 seconds. It takes it 30 seconds to make a rotation. 30 seconds. Amplitude. What's the amplitude?
16.
That's right. It's the radius of the circle. So it would be 16 meters is the amplitude. What's the next question? Okay, how long does this ride go for? Does it say? 2 minutes. Oh. So actually this ride ends right here, 120. Okay, so let's just put that there for ourselves. Okay, so that's all we need to do. So good. This helps us. Our domain. What does that mean our domain's going to be?
It's your 3 from 0 to 1.
That's right. Good. 120 seconds. And what about our range?
From 2 to 3.
What do I got to put first?
Y.
Yeah, because it touches all the points in between. Between.
2.
Yep. Good. Excellent. So we got our domain range. What's next? Well, that's it? Oh, that's quite simple. Okay, well, that's that. That's all there really is to that question. Does that make sense? Okay. Okay, question says, function has a period of 8, and when f is 3, f at x is negative 7, f is 5, f at x is 2. Okay? Okay, so that means at 0, 1, 2, 3, we're at negative 7. So let's scroll down. 1, 2, 3, 4, 5, 6, 7. So at 3, we're at negative 7. At 4, 5, we're at 2. Assume that's 2. We're going to say this is a scale of 1, okay? So far, the only information we have is between the time of 3 and 5. So that distance it moves. So that's in 2 seconds. So we know that in 2 seconds. How far does it move? It moves, let's say meters, okay? 9 meters in 2 seconds. So assuming this is a straight line, okay, we're at 3. That means it's going to be also 2 seconds before that at 1. It's going to be 9 meters even lower. We're assuming the period starts at 0, okay? So at 1, it has to drop another 9 meters. So how low is it going to be? This was at negative 7. At 1, where will we be? F at 1. You know how to figure that out? Do you understand what I'm doing right now? I'm keeping the rate of change the same. So we're assuming this is the rate of change. Okay? At 3, when x is 3, y is negative 7. So we have this point. And when x is 5, y is positive 2. Assuming that this period starts at 0, has a period of 8. Okay, so that means actually after 4 seconds, it changes. Okay, in this question, actually, she doesn't want you to find the function. She wants you to use numbers. Oops, that's not what I want to do. Numbers to get to that same function. Okay, so our two numbers, again, we'll put them in. F at 3 was, what was it? Negative 7. And f at 5 is 2. Okay.
So you just have to multiply them and add them?
Essentially, so first question she says f at 11. So if our period is 8, that means we have to take multiples of 8 off of this number or add it to this number. Now, because 11 is higher than both 3 and 5, we have to take them off of 11, right? So first off, if I subtract 8 from 11, that would be an entire period, right? 11 minus 8, that's 1. That would give us f at 3. And we know from our rule, f at 3 is going to be what? So we know we're at negative 7. Okay. Next one says f at 77. Okay. Well, let's start with what we had there. F, we know we have to go down because we got to get to either 3 or 5, right? If we subtract by 8, what are we going to be at? F at 69. Not close enough, right? So we need to subtract by multiples of 8. So, no, we could still subtract. In fact, you still have to subtract. You subtract by, let's try 8. Oh, the reason she divided was to find the closest number to 77 to multiply by. So, in other words, what she did is we have 77. How many times does 8 go into 77? 9. Okay. Don't even worry about what our rest of our stuff is. Once you have your answer from the top, this number here, we know we have to subtract by a multiple of 8, 9 times. We have to go through the period 9 different times. So 8 times 9 is, yep, so we have 77, subtract 72. What does that give us? F at 5. What's the answer for F at 5? 2. Okay. Next one. What do we have? F at negative 13. In this case, we have to go upwards to get to 3 or 5. Okay? So, in this one, because it's a negative, we can't technically divide. We need a number larger than 13. Okay? So, we know we need to get into the positive realm. So we know that adding just 8 won't be enough. We'll have to go by at least twice. So let's try by twice. This could be a trial and error. Does she divide in this one or no? No, she just uses logic. We're going to add 8 by 2. 2 cycles. 8 by 2 is 16. Okay. Negative 13 plus 16 is F at 3. So what is our answer? So negative 7, right? What's the next one? What is it? 109. Okay. So we need to go downwards in this one, right? This is why we divide again. 8 is our period by 109. So how many times does 8 go into 109? Is it? You have it on the dot?
13.
Yeah, you're right. Okay, so in other words, what we're going to have to do is 109 subtract 8 by 13. Okay? So what is 8 by 13? Subtract 104. What's 109 subtract 104? So F at 5, what's our answer? 2. Is it starting to make sense?
Yeah.
That's what she wants you to do in this. Okay. Just get the multiples of those numbers. Okay, very first question says 81 over 16 to the power of negative 5 over 4. First things first. We have a negative exponent. Flip that fraction. Very good. So the next step is we now have 16 over 81 positive 5 over 4. Okay?
Can you take it? Are you supposed to take it 5 and make it 1 over 4?
Yes, let's split them because what that is one is a power and one is a radical or a root. Okay? So in other words, this can also be said as 5 times a fourth. Okay? Now, a fourth, what that means is the fourth root of something. Okay, so actually I'm going to apply that first. I'm going to bring the fourth into the bracket, so I'm looking for the fourth root of 16 and the fourth root of 81.
Can't you just do it all at once?
What do you mean?
Just do it all at once. 16 divided by 81.
Oh no, we'll get a ridiculous decimal.
Oh.
Yeah, do each of them individually. So what's the fourth root of 16? I know what that is.
Okay. I used the wrong number, that's why.
Do you know? Can you do those on your calculator? Do you know how to do them?
16.
It's 2. Yeah, 2 times 2 times 2 is 2. And a fourth root of 81 should be 3. Okay. Okay. So what we've done now is don't forget, I still have this fifth on the outside. Okay. I've now gotten rid of these roots, and I'm left with 2 or 3 to the power of 5. So now all I do is bring that 5 inside. So what's 2 to the power of 5? And what's 3 to the power of 5? 243. That's it. I'm assuming she wants it in this form. Okay? Whenever you do this stuff, it's usually they want it in this form. You don't want it in the decimal form. This is exact. Okay? 32 divided by 243 is your answer. Does that make sense? Okay, let's try question 2. 8 times 8 to the half. Oh gosh.
8 to the 5 over 2.
Oh, 5 over 2. Divided by 8 to the 4th. Okay? Do you know the rules? Do you remember multiplication rule, division rule, and power rule? All of our bases are the same. So instead of finding the fourth root of 8 and the fifth second root of 8, I can add and subtract them and go through it that way. Okay? Or I can simplify them individually if I really want. Okay? But the fourth root of 8, do me a favor. Get the fourth root of 8. What number would that be? Ridiculous decimal, right? So we're not going to be able to do that. So she wants us to add and subtract. So first thing I'm going to do, these bases are the same, and this is technically to the power of 1. The bases stay the same. So I still have, my next line will still read 8. It's just the power now. What I do is I'm going to add these exponents. So I have to add 1 plus 5 over 2. Well, that becomes 2 over 2 plus 5 over 2, right?
Oh, you have to make them
the
same.
For sure you do.
Okay, so it's 7 over 2.
So we have 8, 7 over 2 divided by 8.
Did you have to subtract it too?
Now I have to subtract it because it's a division here.
But do you have to make the bases the same again?
Yeah.
So
those are fraction rules. You have to do the same.
17 over 4. No, not 17. 14 over 4.
14 over 4. Subtract 1 over 4. What's it going to give you? 13 over 4.
Okay, and then what? Do the same thing.
Yeah, I can find the 13th root and then the 8 to the power of 13. But this might be exact form.
It has to because it's the exact same thing as the 4.
Yeah, so you're not going to get a number. So this is your exact form. Does that make sense? Okay, what about 3? Negative 16. Hold on. You're getting ahead of yourself. So this says negative 16. Oh, not quite. Out of 4. Okay.
If anything that is like that, does that make it positive right away or
no? No. What happens here is there is no fourth root of negative 16. You can't find an even root of a negative because any number times itself is going to be positive. So what your first step is going to be here, apply the power of 3 first. So we'll do 16 to the power of 3. So then it becomes positive, and then we find the fourth root of it, okay? So what's 16, negative 16 to the power of 3? Actually, it's still going to be a
4,096.
Okay, but is it positive or negative? Okay, hold on. She didn't include brackets here, so what she might mean is actually, this is what she might mean. And just like this, where she put the brackets in. Probably means that, as in, sorry. It's really not clear. I don't know why anyone would communicate that way.
That it means that it's actually not there. It's just
the negative is just going to stay to the outside. This is what she's getting at. Because there is no fourth root of negative 16. Even if you put it to the power of 3, you still have a negative number. So it would be undefined. So she's either saying it's undefined or solve it this way and then put a negative in front of it at the end. So you have two options. You have to, yeah. So in this one, it's very solvable. I think it's negative 8 is an answer. Yeah. Yeah, negative 8. So your answer is negative 8. Do you understand that idea?
Yeah. They do it all the time.
All right, 2a. Question says 5th root of x times, to the power of 3 times 3rd root of x to the power of 2. Okay. First of all, let's get rid of these roots. Okay. So to get rid of that root, what that's going to say is x to the root power of 1/5. Do you know how to turn a root into an exponent? Okay. And then we have there.
Mm-hmm.
And then here, I have x squared. Right? And then technically,
isn't it 3 over 2?
1 over 3. We're going to get to that. Okay? So right now, all I've done is separate them. Okay? Now, this is a power rule. In other words, you have to multiply these numbers because it's a power of a power. So I'm going to get x. What is 3 times 1/5? You know? When you do fractions, 5. You don't have to change the fraction. You just got to make it a fraction. So 3 is the same as 3 over 1. So you get 3 over 5.
Oh, you just multiply by the top
Yeah.
number.
You gotta know your fraction rules. You really gotta go through them, because if you don't know them, this stuff will confuse you a lot. Okay. Same idea here. 2 over 1 times 1 over 3 is 2 over 3. So we have x 2 over 3. Now, this is a multiplication rule, which means I have to add the exponents, and in order to add the exponents, the bottoms got to be the same. So, let's make the bottoms the same. We're going to use 15. So, what over 15 for this first one? Yeah, 9 over 15 plus 10. What are we going to get? So, x to the power of 19. That's your answer.
Oh, because it's x.
And B? B says third root of the square root of 64x to the power of 6. Okay. So first let's get rid of the third root. So we'll put in brackets. We now have the square root of 64x to the power of 6, a third. Now let's get rid of our square root. Okay? So then I'm going to have double brackets, okay? So bracket, 64x to the power of 6, 1/2, 1/3. Because this was the power of third, this is the third root, this is the square root. Square root is assume there's a 2 here. Okay? Square root always means one number times itself twice, right? So does that make sense for the 1/2? So if there's no number there, assume it's to this 2. Okay? So now we have those. And technically these are multiplied by each other. Okay, so now that I've separated these, what I'm going to do is, I'm actually going to distribute this. This is 64 to the power of 1, okay? Technically there's a 1 here. So 64 to the power of 1 times x to the power of 6. I'm going to distribute this to both of those. Okay? And it's a power rule, so it means I got to multiply. So I'm going to be left with 64. 1 times 1/2 is just 1/2. And 6 over 2, which is what? What's 6 divided by 2? Yeah, which is just 3, right? And then I still have this a third on the outside, okay? Now actually what I can do here, I can solve the square root of 64. What is the square root of 64? Yeah, so I can simplify that. I now have 8x3 to the third, okay? And again, I'm going to distribute this to the third and to the 8, okay? Because 8 is technically to the power of 1. So I'm going to have 8. 1 times 1/3 is third. And x, what's 3 times 1/3? Just 1. Can I find the third root of 8? Try it. Yeah. It's 2. 2 times 2 is 4, times 2 is 8. So that becomes 2x. So your answer is 2x. This was a tougher one.